Step inside a modern building on a hot summer day, and the air often feels comfortable almost instantly. Hid behind walls and ceilings are fans, ducts, vents, and air conditioning systems designed to move heat away and bring fresh air inside. Most people rarely think about them. Air simply flows where it needs to go. But long before electricity existed, humans faced exactly the same problem. Smoke-filled shelters. Heat became trapped inside buildings. Moisture collected on walls. Stale air made living spaces uncomfortable and sometimes dangerous. Yet ancient builders found ways to control airflow using nothing more than earth, stone, timber, clay, and careful observation. Some underground structures remained surprisingly cool during scorching summers. Some workshops removed smoke without modern chimneys. Some homes maintained airflow even when doors remained closed. How did ancient people understand something they could not even see? The answer lies in one of the most overlooked technologies in human history: the science of moving air. Air is invisible. That fact alone makes ventilation a difficult problem. Water can be seen, fire can be seen, stone and timber can be touched, but air moves silently through spaces, often unnoticed until something goes wrong. For early humans, poor ventilation created serious challenges. Cooking fires produced smoke. Charcoal furnaces generated heat and fumes. Crowded shelters accumulated moisture from breathing. In colder regions, buildings needed to retain warmth without becoming suffocating. In hotter climates, trapped heat could make structures unbearable during the day. The problem became more severe as settlements grew larger. Small temporary shelters could rely on simple openings. Permanent buildings required more sophisticated solutions. A workshop producing pottery or metal tools generated enormous amounts of heat. Underground storage chambers needed airflow to prevent moisture buildup. Granaries required ventilation to keep grain dry and prevent spoilage. Without proper airflow, entire structures could become unhealthy. Ancient builders may not have understood oxygen or atmospheric pressure in scientific terms, but they understood the consequences of stagnant air. And they spent generations learning how to control it. The earliest discoveries probably began with observation. People noticed that smoke behaved differently depending on where a fire was placed. A fire near an opening seemed to burn more efficiently. Smoke often drifted toward gaps in walls. A cave with multiple entrances felt fresher than one with only a single opening. Wind revealed patterns. A breeze entering one side of a shelter often exited through another. Even simple experiments taught valuable lessons. A hole near the roof allowed smoke to escape. An opening near ground level introduced cooler air. Together, these openings created movement. Over time, ancient builders began recognizing that air behaved almost like water. It flowed, it followed pathways, it moved from one place to another. Although invisible, it obeyed predictable rules. Knowledge accumulated slowly. Builders learned from mistakes, structured structures, smoke-filled rooms. Overheated workshops. Each problem provided another lesson. Eventually, ventilation evolved from accidental discovery into intentional design. Entire buildings were planned around airflow. Ancient engineering had begun to harness something nobody could see. Ventilation systems rarely required exotic materials. Instead, builders worked with resources already available around them: stone, clay, earth, timber. Bamboo, reeds, even simple openings could become powerful tools when positioned correctly. Imagine a primitive workshop built beside a river. The foundation begins with compacted earth. Timber posts are cut and raised. The crack of splitting wood echoes through the construction site. Roof beams are stacked and secured. Clay walls are shaped around a wooden frame. At first glance, the structure appears simple. But hidden within its design are carefully planned pathways for air. Near the base of the walls, small openings are left uncovered. These act as air inlets. Cool outside air enters through them naturally. Near the roof, additional openings remain exposed. As heat from fires rises upward, it carries smoke with it. The warm air escapes through the higher vents. Fresh air enters below. Without any moving parts, a continuous circulation system emerges. The process becomes even more impressive inside metalworking workshops. The glow of charcoal illuminates the interior. Sparks rise from the forge, heat radiates outward from the furnace. Without ventilation, the space would quickly become unbearable. Builders therefore create vertical shafts using clay and stone. These shafts guide rising hot air upward. The stronger the fire burns, the stronger the airflow becomes. The system powers itself. Underground structures required different solutions. Storage chambers were often excavated beneath the earth. The weight of soil above provided insulation. Yet moisture remained a constant threat. Builders cut narrow ventilation channels, connecting the chamber to the surface. Air moved slowly through these passages, enough to reduce dampness, enough to preserve stored goods. Some ancient societies developed even more advanced systems. Wind-catching towers appeared in hot regions where summer temperatures became extreme. Tall structures extended above surrounding buildings. Openings faced prevailing winds. Moving air entered the tower and traveled downward into living spaces. Warm air exited elsewhere. The result was natural cooling without mechanical equipment. Throughout these systems, the materials remained remarkably simple. Clay-shaped airflow, stone-stabilized openings, timber-supported structures, earth-insulated chambers. The engineering emerged not from complex materials, but from understanding how those materials interacted with the movement of air. What makes ancient ventilation so fascinating is that it relies on principles still used today. One of the most important is convection. Warm air rises, cool air sinks. Every fire creates this effect. As heated air moves upward, cooler air naturally replaces it. Ancient builders learned to take advantage of this process. High openings released heat. Lower openings supplied fresh air. Together they created circulation. Wind pressure also played a major role. When moving air strikes one side of a structure, pressure increases. On the opposite side, pressure decreases. Air naturally flows between these zones. Properly positioned openings transform this pressure difference into ventilation. Even underground structures benefit from basic physics. The Earth maintains relatively stable temperatures throughout the year. Air moving through underground passages often cools before entering occupied spaces. This principle resembles modern geothermal cooling systems. The remarkable part is that ancient builders discovered these effects without equations or scientific instruments. Their understanding came through experience. Observation became engineering. Practical knowledge became architecture. Invisible forces became predictable tools. Ventilation changed far more than comfort. It transformed productivity. Workshops became safer. Forges operated more efficiently. Pottery kilns performed better. Food storage improved. Communities could build larger and more permanent structures. As settlements expanded into towns and cities, airflow became increasingly important. Public buildings required fresh air. Storage facilities needed moisture control. Industrial activities generated smoke and heat. Ventilation helped solve all of these challenges. Some ancient designs proved so effective that versions remain in use today. Wine towers continue to inspire sustainable architecture. Passive cooling systems appear in modern green buildings. Natural ventilation remains one of the most energy-efficient methods of climate control. The knowledge survived because it worked. Generation after generation inherited techniques refined through centuries of experimentation. Long before mechanical fans existed, airflow had already become an essential part of engineering. Modern technology often hides complexity behind switches and automation. Press a button, and a fan begins spinning. Adjust a thermostat, and a cooling system activates. The process feels effortless. Ancient ventilation reminds us that effective solutions do not always require machinery. Sometimes the most powerful technologies work by cooperating with natural forces rather than resisting them. Ancient builders paid close attention to their environment. They studied wind direction. They observed temperature changes. They adapted structures to local conditions. Their success depended on understanding how nature already worked. That lesson remains valuable today. Whether designing buildings, solving engineering problems, or creating sustainable systems, observation often matters as much as technology. The hidden science behind ancient ventilation is ultimately a story about seeing patterns in the world and using them wisely. The next time you feel a cool breeze moving through a room, consider how long humans have been learning to guide the movement of air, long before electric fans, air conditioners, or modern ventilation systems. Builders were already solving the same challenge using clay, stone, timber, and ingenuity. They transformed invisible airflow into a practical tool. They created cooler homes, safer workshops, and healthier communities. Technology did not begin with machines. It began with observation. It began with experimentation. And sometimes it began with something as simple as noticing where the smoke went. If you enjoyed this exploration of primitive technology, ancient engineering, and forgotten knowledge, consider subscribing for more documentaries on the innovations that shaped human history. And let us know in the comments, which ancient engineering solution do you find most impressive? Their control of fire, water, heat, or even air itself.